Good afternoon, all. Welcome to this new session of our permanent seminar. As the scientific coordinator of the Center for Philosophy of Science of the University of Lisbon, it is my great pleasure to open the March section of our permanent seminar. Today's speaker will be María Caamaño-Alegre. Perdóname que se no sé decir tu nombre.
No, perfecto, perfecto. Gracias.
She is professor at the University of Valladolid. Maria did her PhD with a thesis on the problem of scientific theories in commensurability, okay, at the University of Santiago. And she's a research now on basically on the topics of general philosophy of science, methodology of science, philosophy of language, and epistemology, as you can read in on the bio that we have on our website. I want to thank a lot Maria for accepting our invitation to this session. It is a great pleasure for us, for me, and for all the center to have you on our permanent seminar. And we hope that in the end of this year we can re-invite you to be in Lisbon, because we are trying to build a network in philosophy of science, a very network in philosophy of science. And so let's hope that we can all meet at the end of this year in Lisbon. Let's hope and see. So thank you so much, Maria, for being with us. Sylvia, the floor is yours.
Yeah, thank you. Just a few words. Maria will speak for about 45 minutes. And then there will be the Q&A session. I will moderate the Q&A. So you will just have to write your name in the chat, and I will call everyone. Everyone will have the chance to ask their questions. We are recording this session, but we will stop recording when the presentation stops. So for the Q&A, just feel free. We will not be recording the Q&A, just so everybody can feel free to ask and to comment. So thank you very much, Maria, for accepting the invitation, and the screen is yours.
Well, thank you very much, Sylvia and Joao, for inviting me to join the seminar. It is a great pleasure for me, and I keep my fingers crossed that we can meet in person later on after the summer. I'm going to talk about the notion of construct validity, and trying to explore the relevance of this notion that basically comes from the field, initially from the field of research methodology and test theory, and then it was incorporated as an analytic, as a notion for the analysis of validity, also in the methodology of experimental research. But I think in the literature, in general philosophy of science, this notion is still not much or hardly in use. And I do think that it introduces some elements in the analysis of experimental validity and the empirical evaluation of causal theoretical variables that is really interesting, and so I think it can be very fruitful to take into account this notion. And so the purpose of my talk is to show this potential relevance for different issues. What I'm going to do first is to explain a little this notion of construct validity, and then I'm going to discuss its relevance, focusing on the one hand on the importance that it has to overcome the limitations of the internal-external validity dichotomy, and also to address, to face the Duhem-Quine kind of challenge, related to confirmational holism or to contrastive underdetermination. I think that, as I said before, I think that the notion of construct validity can play an important role in these two areas: the validity taxonomy to make this taxonomy more exhaustive and to understand better the relationship between different kinds of experimental validity, and also to understand how the holistic challenges and the underdetermination challenges can be faced by using a more fine-grained analysis that I think the construct validity analysis can help us with. So the origin of the notion of construct validity can be found in Cronbach's and Mehl's notion introduced in psychological research to assess the validity of tests as measures of constructs. For example, Rosenberg's same-esteem scale or test questionnaire was tested, its construct validity was assessed by checking the predictions that follow from Rosenberg's model about self-esteem, especially one prediction related to the high correlation between self-esteem and participation in school activities in the case of students. So if this correlation was high, the construct validity of Rosenberg's self-esteem test questionnaire was checked on the basis of the variation in participation in school activities. So the higher the values of the self-esteem in Rosenberg's scale, the higher it should be the participation level in school activities. So that was like that was how the work, how the notion worked at the beginning, as it was initially introduced. Later on, Campbell, in the field, not in test theory, but in the field of experimental methodology, introduced the notion of construct validity as an element or an aspect of external validity, as opposed or in contrast to internal validity. And later on, Cook and Campbell, like a couple of decades later, introduced construct validity differently, separately, as a kind of validity different from both external and internal validity. The reason why I'm going to, before we go to the next slide, the reason why construct validity was subsumed under external validity of the experiments was that it was related, it was thought to be related to the identification of potential confounds, and so to the problem of generalizing experimental results from the laboratory or from the experimental setting to the field or to the outside the laboratory. And so construct validity would provide some hints, construct validity analysis, the empirical dimension of the theoretical construct, would provide some clues as to what confounds we should take into account in our attempt to extrapolate an experimental result to outside the laboratory. We have that the main types of validity, the 4 main types of validity, were later on systematized and established by Shadish, Cook, and Campbell in 2002. And so we can see the place that construct validity had in this taxonomy, which is still very much in use, and the one I think usually applied in the analysis of experimental validity. So we have as a first type of validity, statistical conclusion validity, which concerns the adequate use of statistics to infer whether the presumed independent and dependent variables are correlated. Internal validity, referring to whether the covariation between those variables result from a causal relationship. Construct validity, which concerns the extent to which a particular indicator, or more usually a set of indicators, represents a given theoretical concept. And finally, external validity, which refers to the adequacy of generalizations from results obtained in an experimental setting to phenomena out of such setting. So a very important change from the initial notion of construct validity to the later notion as characterized by Shadish and his collaborators is that construct validity is established from a functional approach. So causal generalization is understood that what it has to do with a causal, theoretical causal generalization from research operations to higher order constructs. It means that what is to be assessed is the adequacy of generalizing from causal connections between observable variables to causal connections with non-observable variables or higher order constructs. So the inference again from this connection between observable variables to a higher order constructs that is defined, characterized empirically on the basis of those observable variables. So the construct is understood as the theoretical construct as having the function of providing a causal explanation in terms of non-observable variables. It is important to realize that this functional approach was applied to the 4 main elements of an experiment under causal relationships. So it was applied to particular units of a domain, to interventions, to the kind of manipulation or intervention operations carried out, to observations or outcomes, and to settings on which data are collected. So the theory that provides the theoretical context in which a construct is inserted or it belongs, the theory has some assumptions related to these different elements involved in an experiment or that are part of an experiment. And all the empirical side that is related in what the theory establishes, related to the domain to which it's going to be applied, or the empirical implications related to the intervention that is going to be employed to test the theory. This kind of connection between theory and the empirical basis, experimental basis in this case, is what it should be analyzed. So, as I said before, is construct validity, and the way that is characterized, the way this notion is characterized in the experimental methodology, is a way that makes it clear that is different, should be distinguished from external validity. And so in this table, we can see the contrast between these two notions. Construct validity concerns representation, whereas external validity has to do with extrapolation of experimental results. Construct validity has to do with how well the construct is represented by the representation relationship is actually bidirectional. How well the empirical indicators, empirical data represent the construct, the theoretical construct, and how well the construct is representing the phenomena, the observable phenomena, characterized by means of those empirical data. Construct validity is related to the inference, the presence of a theoretical construct, involves inferring that presence of the postulated attribute or entity or relation, while external validity involves inferring degree of replication across different constructs and populations. The replication of the same experimental result, of the same result obtained in the experimental context through different populations. Construct validity is about identifying theoretical causal variables and relations, while external validity has to do or involves identifying sources of variation in causal relationships, the problem of the confounds that I was mentioning before. And interestingly, also random sampling is useful for the maximization or the pursuit of both kinds of validity, construct and external, but differently. Random sampling is useful to detect theoretical causal variables by making potential confounds homogeneously distributed. And random sampling is useful also for external validity, to minimize the effect of confounding variables by homogeneously distributing potential sources of variation. If we think about a couple of examples in thinking about the field of experimentation, we have, for example, the construct ether drift, which we can say it was, we can ask about the construct validity of ether drift, of this theoretical concept, And we can ask about the construct validity of the Michelson-Morley experiment to determine the presence of ether drift of the theoretical construct. There were two, in this experiment, in the Michelson-Morley experiment, there were two empirical indicators used: the displacements of the interference fringes and the changes in the speed of light that were actually assumed to be detectable by those displacements of the interference fringes. The main, as we can see, the main idea, or the way that the experiment was designed, relied heavily on the assumption that ether drift was characterized as a medium, and the idea that the drift that would be caused by the rotation of the Earth relatively to the ether drift, to this medium, the drift would cause a change in the velocity of light in case that the rays of light were making round trips in two perpendicular directions. In this case, each ray would be affected differently by the ether drift, and so we would have an interference. We would have interference fringes that would allow us to detect those changes in the velocity of light, the same way as it was detected the change in the velocity of light in water, for example. So in this case, the empirical indicators for ether drift and ultimately for ether were obtained through the consideration of a high correlation, so the statistical conclusion and the internal validity of the procedure used by Michelson and Morley was high, can be considered high, because already in previous experiments that correlation and that causal connection was clearly established. And there is again a very robust causal connection between these changes on the speed of light depending on changes in the medium and the changes in the interference fringes. The construct validity here again is can be acknowledged to be high for the reason that being affecting the speed of light can be considered a very distinctive empirical property of a medium. So that's the assumption that is applied here to test the theoretical construct is an assumption that has been corroborated to a very high degree. And the causal mechanisms involved in the procedure are also well known and well established. The external validity in this case is also high because the experimental setting where the experiment is performed doesn't change any of the main variables involved, the speed of light and the orbital speed of the Earth. So we don't have potential confounds threatening the validity, the external validity of the experiment. And to take a completely different example, the use of an experiment on the basis of a dictator game kind of experiment. The construct in this case that was checked for validity was altruism. And the main empirical indicator in this case is whether to detect an altruistic attitude in a subject is whether the subject splits the money in half or something very close to that between the two gamers. Here we have that the empirical indicator, the equal distribution of the money, is considered to capture a distinctive feature of the theoretical construct, altruism. That behavior is supposed to show that subjects are not thinking only about themselves, but that are worried, they care about other subjects, and they want other subjects they care about the well-being of other subjects. So the empirical indicator again is money equal distribution, and the theoretical construct, as I said, is altruism. The statistical conclusion and internal validity should be established here, checking the correlation between this situation, the freedom to distribute money for a subject, and the correlation between that situation and the distribution of equal amounts of money. Construct validity, and as we know, the real experiments performed show that there is a significant correlation between both things. Construct validity, in this case, the concept involved is that of altruism, needs to be examined carefully with respect to this single empirical indicator, especially because we have that the equal distribution of money can be affected, that decision, that behavior, can be affected by other constructs, can be affected by other attitudes different from altruism. And so this brings us to the problem of external validity and to the problem of general extrapolating the result to other situations outside the laboratory. And here we do have a case completely opposite, different from the case related to ether, because in this case, the laboratory may create changes in the subject's attitudes. The experimenter bias may be influencing the subject. The wish to comply with social norms may be the key factor, the key causal factor making the subject split the money into halves. And also there are different variables that may be changing the results, like, for example, the fact that the computer is the opponent in this game and not a real human being. So given the wide space for confounds, here we have that the empirical indicator doesn't cover the breadth of the theoretical construct, and the experimental situation it doesn't determine key empirical aspects, empirical variables that would be required to exclude that other constructs are the ones that are playing a role in that situation. So let's focus now on the threats to construct validity. And just recall briefly that the usual threats to experimental validity, generally the ones that are most often mentioned are noises and confounds, and the artificiality of testing or experimental settings, and together with selection biases. And these problems, again, these problems are the ones most often mentioned as problems affecting experimental research, but these problems actually mainly affect statistical conclusion on internal validity in the case of noises and confounds, and external validity in the case of artificiality and selection biases. But sometimes what is overlooked, and I think it's interesting to emphasize these threats, are the threats related to construct validity. Here, the main threats are incompleteness or construct underrepresentation. I was using the example of the experiment to check the construct of altruism. And here the problem, of course, is that empirical indicators leave out something that should be included, and the problem of irrelevancy or construct irrelevant variance. Here, empirical indicators include something that should be left out. And this second threat may sound more strange or more difficult to understand, but irrelevancy may come as a result of applying mono-operation as a result of operationalization of the procedure, using a procedure, an experimental procedure that is the only one, the single procedure to detect a certain construct, as opposed to using multiple operations and multiple procedures that converge in and triangulate a reference, the construct, the same construct. If a single construct if a single operation, experimental operation is used, the very features of the experimental procedure may introduce irrelevancy, may introduce confounds that systematically are associated with a construct. And so the only way to avoid the inclusion of irrelevant aspects is to use different procedures and to be able to find not only different empirical indicators, but different ways, different procedures to detect those empirical indicators. In construct validity assessment, a theoretical construct is always tested indirectly by inference from the interrelationships between different indicators and the theory postulating such interrelationships. This indirect character of the construct validation makes it more difficult to handle from a methodological point of view. But as I emphasized a moment ago, a robust assessment of construct validity would require multiply operationalized constructs. So what has been the predominant view, if we analyze what are the usual strategies to assess construct validity, the predominant view favor what I would call a horizontal evaluation. So the question that researchers try to answer when assessing construct validity is, what are the empirical indicators for a construct and how should they relate to each other? To answer this question, they'll examine and look for convergent and discriminant evidence. Convergent evidence consists in different empirical indicators that correlate as established by the theory to which the construct belongs. And discriminate evidence is related to the specific distinctive features of a construct as opposed to other constructs. And so it is important also to find this kind of evidence so that we can rule out potentially alternative constructs. So the methods, in what I'm calling this horizontal evaluation of construct validity, the methods applied are the multi-trait, multi-method matrix, originally put forward by Campbell and Fiske, which it is a procedure to triangulate by using different operations to check the presence of the same construct, and also to see if, by using different methods, of course, the contrary to what the validity would imply happens, which is that using different methods to measure the same construct, we obtain different results. So the breadth of the number of traits is important, of empirical indicators, but also the variety of operations to detect those traits. Also, the factorial analysis is used, and in this case, again, the idea is to establish factors that are determined on the basis of different sets of empirical indicators. Here we have an example of factor analysis to evaluate the construct validity of pain, and we can see that in this case, pain, the authors were checking whether the construct of pain, taking into account two empirical features that would be intensity and interference with life, with lifestyle or activity, whether these two empirical indicators were adequate, and they were using these factors were decomposed in different sets of indicators, as you can see in the squares. And they, in their study, they found out that it would be important to refine the construct of pain by distinguishing activity interference and effective interference, because there is a distinctive effect of pain in those two dimensions of life. So that would be just an example, a way to analyze construct validity by, as I said before, well, trying to cover the whole breadth of empirical implications from a construct, a theoretical construct. I think it's important to in order to not only robustly test construct validity, but also severely test construct validity, I think it's important to consider also or to think about a vertical kind of evaluation. And the question to answer here would be, how should the empirical indicators for a construct be obtained? The examination here of the auxiliary assumptions specifying the relation between the operations and the empirical indicators would be most needed, or would be the key aspect. To this end, I think that it is important. This task would require the essential goal of this task would be to see whether the empirical data is validly obtained. So it's related to checking the validity of the instrumental procedures, experimental design procedures to obtain the empirical data. And so it would be important to focus not only in what the empirical interpretation of the theoretical construct is, but how, once that is empirically interpreted, how the empirical data is obtained using what instruments, and by using those instruments, what causal mechanisms related to the functioning of the instruments are operating, and of course making explicit the theory about the causal mechanisms that on which the functioning of the instrument depend. So that's what I'm calling here the vertical evaluation, because it is related to the validity of the way the empirical data is obtained. And of course, that kind of analysis would make it possible to see whether there is some theory latedness on those assumptions related to the instrument that we are using to obtain the empirical data. Here, I think it would be useful as a method to test severely the construct validity of a procedure. It would be important, I think it would be useful to apply the hierarchy of models approach introduced and developed initially by Patrick Suppis and then refined by Deborah Mayo. That would help to differentiate different models, from the theoretical models to the experimental models, going downwards to the experimental models, to the data models, and to ceteris paribus and experimental design assumptions. And that would be the scheme of the hierarchy. And it would be important to determine the linkage, what Deborah Mayo calls the linkage models between each level in the hierarchy. So to come back to the relevance of the notion of construct validity, so far I just characterized the notion and mentioned some, I think, some important ways to enrich this notion, or to make it more accurate and more useful. To come back to the question of the relevance of this notion in the validity taxonomy for experimental research, it is easy to find now numerous papers that show that discuss the dissatisfaction with the external-internal validity dichotomy, especially in what was usually presented as a trade-off view of the internal-external validity. Usually the cliché, stereotypical idea was, well, if the internal validity of an experiment is high, it means that it's the conditions are very restrictive. And if that's the case, the external validity is going to be low. So the trade-off was understood in this way. But actually, as I said, different authors have shown that there is an incompatibility between the trade-off condition and the condition of internal validity as a pre-requirement for external validity. Because again, if there is no internal validity, there is no causal connection to be actually identify or search outside the laboratory. So actually the search for causal connections need the isolation method of the lab experiments, and only after that has been established, the experimental validity can be an issue or can be maximized. And also some authors criticize that the notion of artificiality is very, very vague. And if it's made precise, it may conflate actually with the requirement of isolation, experimental isolation of the causal variables under study. So these are some of the criticisms to the internal-external traditional dichotomy. And also the idea that if experiments only, experimentation is only pursued in a way that internal and external validity are maximized, then the possibility of theoretical causal inference is very limited. That's internal and external validity may be satisfied, and still the question about what theoretical construct is the best one to interpret the results of an experiment would still be open. And thus, in this quote by Cook, that is the problem that is mentioned. Recently, also Deaton and Cartwright have made similar claims, but in connection with what would be an unreflective use of randomization. And again, as you can see in the quote, they think that the description given to the treatment is a construct, also the description of what the control intervention is, and the description of the population enrolled in the study. And so it takes a web of theory and evidence to support the claims that these descriptions are the right ones. And taking a step further, some authors like Martel Garcia and Watkett-Cohn have claimed that construct validity can actually, the attempt or the work in maximizing construct validity can actually help obtaining external validity. And partly their argument is that analyzing the theoretical assumptions related to how the theory should be applied to empirical domains what the theory implies for the empirical domain, making this explicit would help also. That explicitation would include some ideas as to the most likely confounds. So the more developed and the more detailed that the empirical interpretation of a construct is, the more clues we have as to what potential confounds could prevent a causal connection obtained in the lab or determined in the lab, not holding outside the lab. Related to the validity of theoretical causal inference, here we have different strategies that are related to this issue. Strategies that are mentioned by Cook and his collaborators, and are related to these strategies to different ways of making inferences from empirical indicators to causal dimensions, or for justifying that connection between empirical indicators and theoretical causal dimensions. The first strategy is to take into account the theory in which the construct is included, and check for the implications about how empirical indicators should correlate. A second strategy is to go for the most instinctive or prototypical empirical dimensions of a causal category. And a third strategy would be to use the multi-trait, multi-method approach that I mentioned before, that Campbell and Fiske suggested. And then in more in a specific area related to intervention programs, again, the strategy is to choose a distinctive relevant feature of the program. Very briefly, I'm going to make some comments on the relation of construct validity with the Duhem-Quine problem. When I refer to the vertical assessment of construct validity, somehow I was already anticipating some of the ideas that I wanted to comment now. The Duhem-Quine problem is usually characterized as including two different issues. On the one hand, the problem of confirmation holism or holistic underdetermination. And what it means is that when testing a theory, and here when trying to validate a construct, if the construct is not validated, we can always blame not the construct, but some auxiliary assumption that we have endorsed or included in order to be able to empirically test the construct. And since we have to, the empirical consequences cannot be drawn without endorsing some auxiliary assumptions, there is no way, according to this challenge, there is no way to pinpoint, to identify the specific source of the error. The Duhem-Quine challenge is also understood as related to what is called contrastive underdetermination. And in this case, the problem is that alternative theories may be equally capable of making the right predictions in the same domain. And if this is the case, we have a problem of empirical equivalence between alternative different theories. And again, it's not clear how to address these challenges. And I think that one of the ideas related to the construct validity assessment, in particular, the emphasis on discriminant evidence, the search for discriminant evidence, that's a strategy to apply in the case of contrastive underdetermination, and to try to find the specific empirical indicators for one construct essential for one theory, and for the other construct that wouldn't share the other construct that would be essentially as part of the content of the alternative theory. So discriminant, the active search for discriminant evidence would be an important issue, and that's also a Popperian subject that here we can see again in the context of the construct validity discussion. And we could apply also in the case of holistic confirmation, holism. Here, I think there is even more possibility of combining different methodological clues that I have been describing here in connection with construct validity, that are related, all of them, to the possibility of pinpointing or identifying different elements of the inquiry, different constructs, and different empirical indicators for the construct. So dividing the empirical testing of a theory or a hypothesis, dividing the testing of a construct into different empirical indicators, and dividing the testing of how the indicators are obtained by applying the vertical kind of evaluation that would depend, of course, in being able to distinguish different levels of theoretical assumptions related to the instruments or the measures of the confounds and ceteris paribus, and different elements of the experimental procedure. So I think that's I'm going to stop here